Okay, today we're going to do a circular motion lab. You're going to need your little physics lab manual that we're starting to create. If you open it up, it should have the lab for circular motion 1, and you will need a lab sheet to go with it. These can also all be printed offline on the website if you don't have it in the classroom. On your table, you will find a bin. You should have the following items in your bin. You should have a little plastic tube or a glass tube as such. You should have a rubber stopper. That's going to be a weight we're going to swing around our head. The reason where you can use all sorts of weights, the reason we're using a rubber stopper is it won't break my window if you let it go, and it won't hurt anybody too bad if you get bopped inside the head. You should have a weight. A weight you can measure. If you don't have a weight or you're doing this at home, you can use washers, but you're going to have to weigh them. I like the weights. You want a weight with a hook on it, with the weight printed on it. You will need a timing device, a stopwatch, or you can use your cell phone or any other device. Scissors to cut some line. And you will want a marker to mark the line. Now when I say line, I mean string or fishing string. In the back of the classroom, I have some fishing string like this. Whatever kind of line you use, you want it to be slick. It's got to be able to slide in and out of that little tube I just showed you without any friction, or at least friction. Cotton line tends to stick. It doesn't work as well. You will need about 1.5 meters of it. So you are going to grab a meter stick. Where it goes from number 0 to 100, those are centimeters. This is the meter side of the meter stick. Where it goes 0 to 39, a little over 39, this is inches. This is just so comparison to the American system. 36 inches is a yardstick. You can see a meter's a little bar. We're going to use a meter because it's going to be our base measurement. 1 meter makes the math easy because it's easy to divide or multiply by 1. What you're going to want to do is get about 1 meter of the line, or at least 1.5 meters. You should have a little line hanging off here. Grab your meter stick. It's not an exact measurement as long as you have a little bit over. There's about 1 meter, about 1.5 meters. Take your scissor. When you cut it, if you're in the classroom, make sure you leave a little bit of the line dangling out. Don't let it go in the little hole. It makes it a real pain in the butt to try to pull it out later. Now, what you are going to do is you are going to thread it through the tube. Doesn't matter which way. And I'm going to run this really quick. You're going to thread it through the tube. On one end, you are going to tie the stopper. So tie a nice knot. If you don't know how to tie a nice knot, tie a lot. But you don't want it to be able to fly off. On the other end, you will tie a little loop, not a knot. You're going to tie a loop. And on the loop, you are going to be able to hang the weight. Once you have the stopper tied on, what you're going to do, because I'm not going to waste time, is you're going to measure from the end of the stopper to the tube. You're going to measure 1 meter. This is where your buddies can help you. Remember, we're using a 1 meter stick. So I'm just going to measure 1 meter. Nice on the line. At the 1 meter mark, take your marker. Yay, I'm all tangled up. Take your marker and color it black. That way when the black line is here on the end of the meter, I know from the black line to my stopper is going to be 1 meter. That is going to be the radius of the circle I'm going to create swinging this over my head. A little hint, I also put a little black mark on the bottom side. So when I'm looking at it, if I see a black mark here and a black mark here, I know my radius is exactly 1 meter. Got that? Cool. So let me show you a finished example. This will be a finished example. Notice I have a loop so I can take weights on and off. This is so we can try the experiment with different weights. I have my metal tube that slides in and out really good. On this end, I have my little washer hanging. It's probably not going to show on the camera, but at 1 meter, I do have a little black mark. So if I look on here, I can see a little black mark for the 1 meter. Now, once your gear is set up, I'm going to show you what to do. Hold on a second, I'm going to stop the camera and set up and then show it to you. Okay, now we are start to set it up. What I am going to do is find a clear area. Remember my radius from the center of this out is going to be at least 1 meter. So make sure I'm clear a meter behind me, make sure I'm clear a meter in front of me, and on each side. Also make sure I'm not near anything breakable. Let everybody know I'm going to start swinging. What I start doing is I make sure the weight's off the ground and I start rotating this over my head. Just a little bit. I want it to be parallel to the ground. I don't want strange loops going up and down like this. I don't want it like I want it to be like a helicopter. As level it is. I'm going to start feeding it out until I get to my 1 meter mark. I can tell that by the blacks, little dots. Now, what's going to happen is once I'm here, I'm going to find the speed where if my weight's off the ground, where it stays with my radius at exactly 1 meter. You're going to notice if I slow down, if I start going slow, the weight's going to drop. My radius is going to shrink. So I'm going too slow. If I go too fast, the washer's going to go out and start hitting things. So I'm going too fast. That means my radius is bigger than 1 meter. So you got to find that ideal time. Then you're going to get your partner. My partner's behind the camera with a stopwatch or a timer. What he's going to do is they're going to pick where the where the stopper's at 1 point. And they're going to start timing when the stopper hits that point. And they're going to count 10 revolutions. 10. You don't want just 1 revolution. You want 10 revolutions, and you're going to get the time of 10 revolutions. Okay, you ready? Excellent. Okay, then you can put it down and leave the camera running. I timed it on here. If you are doing this, if you are homebound or doing this as a makeup, your time for 9 revolutions will be 9 seconds and 53/100ths of a second, 9.53. This is going to be important. This number here, we're going to take it and we're going to divide it by 10. Remember, we timed 10 revolutions. By dividing this by 10, this will give me my time for 1 revolution or 1 rotation. That is the time we're going to use in most of our calculations on the lab sheet. The more revolutions I time and divide by that number, the more accurate I'm going to get. If I just try to use my stopwatch and start and stop it for 1 revolution, it would be pretty horrible. Also, dividing by 10 is pretty easy. I would just move the decimal point. So I know my time for 1 revolution will be 0.95 seconds. No reason to go out to the thousands. This thing only times to the hundredth. From this point, you're going to take this data and do it in the lab sheet and follow the directions. All this information is also online. Okay, I'm back. In the quick pause, we did a second run. Remember, science is repeatable. This time on the second run, my lab partner, who did it because we wanted 2 people to do it, on trial number 2, the time of 10 revolutions was 9.45 seconds. You'll need this to fill out your lab sheet. Now we're going to go to the third and final run for a comparison. In the third and final run, we are going to increase the weight. In this case, we're going to double it. We're using 2 100-gram weights instead of 1 100-gram weight. But we're going to do the same thing. We're going to rotate it 10 times, and then we will divide that by 10 to get the time of 1 revolution. I always start with small. Small revolutions are easier to get going. Look for my marks. Get going till I'm up to the 10 or up to the 1 meter mark. You're going to discover it may take a little more playing to get it going. The 100 meters is a much harder one to control with the time. Okay, lab partner, I am there. I am rotating. Start timing when you can. Remember, we're only timing for 10 revolutions. We got to keep the speed the same. Got it? Yeah. Okay, now I am done. At this point, I will store everything. Leave the camera running for a second. I will store everything and put it away. For the heavy weight, your time for 10 revolutions is 7.29 seconds. As you guessed, it was probably a little faster because it's going with a faster speed to compensate for the weight. This is all the information you should need to fill out the lab sheet. Thank you. Okay, now that you've had a chance to work on the worksheet, a couple formulas you may need. You may notice in the first formula for centripetal acceleration, you need velocity. It would be velocity squared. Let's go back to our basics. Remember, velocity or speed is simply distance over time. In this case, our spinning little stopper, the distance it's traveling is the circumference of a circle with a 1 meter radius. Circumference equals 2 pi r. In our case, r is 1. A great reason to pick it. So if I use that as a substitution, my distance is going to equal 2 pi times 1. I'm not going to put the 1 up there. Divided by time. The time we're using will be the time of 1 revolution. In most cases, it should be a little under a second. Remember, you took the time of 10 revolutions, you divided that by 10, and that gives us the time of 1 revolution. Another thing I notice a lot of people make mistakes on is for mass. In the formulas, mass is in the form of kilograms. On our scale, we tend to measure it in grams. If you take grams, the conversion for 1 kilogram is 1,000 grams. So what you want to do is whatever you have in grams, you're going to divide by 1,000. Or, if you have a certain amount in grams, you can always just move the decimal 3 times, for those who like that. So in most of our cases, we are dealing with a 100 gram weight. That'd be 100.0. 1, 2, 3. So 100 grams will equal 0.1 kilograms. That should still make the math easy. Good luck on your worksheet.